Good morning students, this is Latif sir. In this video today I'll discuss about carbon and its compound. This is the chapter 9 of class 8 chemistry. So what is carbon? Carbon, it is the sixth element in the periodic table. It is the sixth element in the periodic table and its chemical symbol is C. An atom of carbon has 6 proton and 6 electron and 6 neutron. So its atomic number is 6 and mass number is 12. And it is present in almost all items that we commonly see around us, like in sugar, in paper, in cloth, food, medicine, carbohydrate, protein, fat, petrol, diesel. In all these items carbon is present. So carbon has very important role in our day-to-day life. Okay, so carbon is the fourth most abundant element in the universe after hydrogen, helium and oxygen, and it is a non-metal and it exists in free state as well as in combined state. Okay, carbon is found in free state. Carbon is found in free state in the form of diamond, graphite and coal, and it is also found in combined state in different compound, in carbon monoxide, in carbon dioxide, in metal carbonate, in metal bicarbonate. In all this compound carbon is present in combined state. Okay, in limestone that is CaCO3, in calamine that is ZnCO3, in washing soda that is Na2CO3. In all this compound carbon is present in combined state. Okay, so carbon can exist in free state as well as in combined state. Carbon has tetravalency, that is it is tetravalent element, that is it has 4 hand and it has a unique property. Carbon has a unique property that is called catenation property of carbon. So what is catenation? Catenation property of carbon, it is the unique property of carbon. It is the self-linking of carbon atoms. Carbon can form long chain by self-linking. Okay, and this unique property of carbon is called catenation property. Forming of chain by self-linkage, this property of carbon is called catenation property. Atoms of carbon can link together by covalent bond. Atoms of carbon can link together by covalent bond, to form a long chain molecules, and this property of carbon is called catenation property of carbon. And due to this catenation property of carbon alone forms more compounds than all the other elements put together. Okay, so in all complexes found in living organisms such as blood, hormones, proteins, DNA, RNA, enzymes, all these complex molecules in living organisms made up of carbon. Okay, DNA, RNA, enzymes, hormone, blood. So large is the number of these complex molecules made up of carbon. And you can study about the compounds of carbon in the branch of chemistry which is known as organic chemistry. In this branch of chemistry you can study about the compounds of carbon. Okay. Now see, two tables are given. Carbon can form two type of compounds: inorganic compounds and organic compounds. Maximum compounds of carbons are known as organic compounds. Organic compounds means carbon must be present in organic compound. Okay, in few compounds of carbon, they are not organic compounds, they are inorganic compounds, like gaseous inorganic compounds like carbon monoxide, carbon dioxide, metal carbonate, metal bicarbonate. In all these compounds, carbon dioxide, carbon monoxide, metal carbonate, that is CaCO3, NaHCO3, Na2CO3, all these metal carbonate, bicarbonates. In these compounds carbon is present, although these are inorganic compounds, not organic compounds. Okay, so oxide of carbon, carbonates and bicarbonates. Oxide of carbon, that is CO, CO2, carbonates, bicarbonates, that is NaHCO3, Na2CO3. These are not organic compounds, These are inorganic compounds because these compounds do not further form long chain. Okay, so these are inorganic compounds made up of carbon. And now see organic compounds of carbon. There are many types of organic compounds of carbon, like hydrocarbon, alcohol, acid, sugar. Okay, hydrocarbon like methane, ethane. These are organic hydrocarbon. Methyl alcohol, ethyl alcohol, these are organic alcohol. Carbonic acid, acetic acid, CH3COH, formic acid, HCOH. These are organic acid. Sugar, that is glucose, fructose, maltose, starch, all these are organic sugar. Okay, so carbon can form both inorganic and organic compound, and maximum compounds of carbon are known as organic compounds. Now see allotropy. What is allotropy? Allotropy Allotropy is the existence of an element in two or more forms in the same physical state. Allotropy is the existence of an element in two or more forms in the same physical state, and all these forms have different physical property but same chemical property, because same element is present in all the form. So allotropy is the existence of an element in two or more forms in the same physical state, and all these forms have same chemical property but different physical property. And the defined forms of an element are known as allotropic form or allotropes. Important term, allotropy. So carbon has many allotropic form. Okay, example of allotropy is given. Main allotropes of phosphorus. Phosphorus has three allotropic form: white phosphorus, red phosphorus, and black phosphorus. Phosphorus has three allotropic form: white, red, and black phosphorus. Similarly, sulfur has two allotropic form, that is rhombic sulfur and monoclinic sulfur. Okay, in this chapter you have to read mainly about allotropic form of carbon. Allotropes of carbon, that is different allotropic form of carbon, classified in two categories. One is crystalline allotropic form of carbon, another is amorphous allotropic form of carbon. Crystalline allotropic form of carbons are diamond, graphite, and fullerene. These three are crystalline allotropic form of carbon. And amorphous allotropic form of carbons are charcoal, coal, lamp black, gas carbon, coke. You have to study about all these different allotropic form of carbon. Okay, so here difference between crystalline and amorphous form of carbon, allotropic form of carbons, are given here. You can see crystalline means this allotropic form of carbon has definite geometric form. Okay, they have crystalline forms of carbon have definite geometrical form, definite shape, but amorphous, they do not have definite geometrical form. They are like powder type. Okay, powder type forms of carbon are known as amorphous form. So first, crystalline form of carbon. In crystalline form of allotropic form of carbon, they have regular arrangement over a long range. They have regular arrangement over a long range, but amorphous form of carbon, they have regular arrangement over a short range. Amorphous form of carbon, they have a regular arrangement over a short range. Now see, crystalline form, they have definite geometrical forms, sharp edges, and plane surfaces. Okay, and these forms are referred to as crystals. And amorphous forms, they do not have definite geometrical forms, do not have sharp edges, and do not have plane surfaces. They are actually powder type. Okay, do not have definite geometrical forms. Crystalline forms have sharp melting point. Crystalline forms have some sharp melting point, but amorphous forms do not have sharp melting point. They melt over a range of temperature. Amorphous forms melts over a range of temperature. and their melting point and boiling points are low. Now see amorphous crystalline form of carbon, that is diamond, graphite. I have already told diamond, graphite and fullerenes. These three are crystalline forms of carbon, and amorphous form of carbons are charcoal, coal, lamp black. These are amorphous form of carbon. So difference between amorphous form and crystalline form is given here. Okay, you have to read. So now see first crystalline form of carbon. Crystalline form of carbon. So first crystalline form is diamond. Diamond structure of diamond is given here. You can see tetrahedral structure of diamond. It is written here. Arrangement of carbon in diamonds are tetrahedral arrangement. Tetrahedral structure of diamond. In diamond, each carbon atom is linked with four other carbon. Each carbon atom is linked with four other carbon atoms in a tetrahedral shape. The shape is showing here. Figure 9.3. Tetrahedral structure of carbon of diamond. Okay, and this forms the basic unit of crystal structure of diamond. The basic units repeats and extend in all direction to form an octahedral shape. Okay, so in diamond, each carbon atom is linked with four other carbon atom in a tetrahedral shape. Now see physical properties of diamond. Physical properties of diamond. Diamond is the hardest form among the all forms of carbon. In fact, it is the hardest naturally occurring substance. Diamond is the hardest form among all the form of carbon, and it is the hardest naturally occurring substance. And it is colorless, lustrous crystalline solid. Colorless, lustrous crystalline solid. It is transparent and it is insoluble in any solvent. Diamond is insoluble in any solvent. Okay, and it is a good conductor of heat but bad conductor of electricity. Okay, it is good conductor of heat but bad conductor of electricity. Now see use of diamond. Different uses of diamond. Diamond used as a precious gem in jewelry. It is used for cutting glass and drilling rocks, and it is used in manufacture of very thin wires such as tungsten wire for use as the filament in electric bulb. So these are the use of diamond. Next allotropic form of carbon is next crystalline allotropic form of carbon is graphite. Structure of graphite is shown in figures 9.6. Layered hexagonal structure of graphite. Layered hexagonal structure of graphite. in graphite each carbon atom is linked with three other carbon atoms forming a flat layered hexagonal. In graphite, each carbon atom is linked with three other carbon atoms forming a flat or layered hexagonal unit. This basic unit repeats itself and form a layered network, and there is a weak force of attraction between the layers. So structure of graphite, layered hexagonal structure of graphite. Remember this term, layered hexagonal structure. Physical properties of graphite. Graphite is a soft and flaky. It is grayish black and lustrous crystalline solid. It is insoluble in most of the solvent. It is a good conductor of heat and electricity. And graphite is the most stable. Remember that graphite is the most stable allotropic form of carbon. Okay. Use of graphite. There are many uses of graphite. You know that graphite is used as an electrode in dry cell. It is used in pencil. Okay, lead pencil. So it is mixed with clay and used as lead pencil because it is very soft and flaky and leaves a grayish black mark when pressed on a paper. Graphite is mixed with clay and used as the lead pencils because it is a soft, flaky, and leaves a grayish-black mark when pressed on a paper. And graphite is used in nuclear reactor as moderator to slow down or to control the speed of neutron. Okay, it is used in nuclear reactor, and it is used as lubricant in machine. Okay, and it is also used for making pigment, polishes, and paints. So these are different uses of graphite. Difference between diamond and graphite you have to read. Very easy points are given. It is colorless, transparent, it is grayish black, and grayish black in color and shiny. It does not leave a mark on paper, but graphite, on applying pressure, it leaves a black or gray mark on paper. Diamond is hard to touch, it is soft and grazy to touch. Okay, structure of diamond, it is tetrahedral structure of graphite is hexagonal layered structure. Diamond is a bad conductor of electricity and good conductor of heat, but graphite is a good conductor of heat and electricity. So these are some difference between diamond and graphite you have to remember. Now see, third crystalline form of carbon is fullerene. Fullerene fullerene are a form of carbon consisting of series of carbon atoms arranged to form hollow cage-like spherical molecules or cylinder. The number of carbon atoms that make up a fullerene can vary from 30 to 900. Fullerene can be found in the form of hollow sphere known as buckyball. Fullerene may also be cylindrical, and these fullerenes are called carbon nanotubes. Okay, so in fullerene, it is the third type of crystalline form of carbon. It can exist in different shape, hollow or cage-like or spherical shape, okay, or in cylindrical, and number of carbon atom in fullerene varies from 30 to 900. Okay, so physical properties of fullerene. Fullerene are found in nature in small quantity. They can be found in soot, interstellar dust, and their color depends on the number of carbon atoms present in them, and they are soluble in many solvents. Use of fullerene: they are used as insulator. Fullerenes are used as insulator. They are used as catalyst. They are used as semiconductor in computer and flat screen TVs. Some fullerenes are used as superconductor. So these are some use of fullerene. Okay, now the amorphous form of carbon, that is amorphous form of carbon, that is charcoal, coal, lamp black, gas carbon, coke. So first amorphous form of carbon is charcoal. Charcoal is a black, soft and porous solid. And when organic substance such as wood, sugar, bone are heated strongly in absence of air in a closed container, charcoal is formed. And this method is known as destructive distillation. Okay, so charcoal is formed by destructive distillation. Okay, so the process, what is the definition of destructive distillation? The process of heating organic substances strongly in absence of air is known as destructive distillation. Remember the term. Okay, the process of heating organic substances strongly in absence of air is known as destructive distillation. So after destructive distillation of organic substances, charcoal is formed. Use of charcoal. Charcoal is porous and it has a large surface area with less volume, and it is used as adsorbent to absorb gases and colors. Okay, and hence it is used in gas marks for industrial and military purpose, and it is also used as decolorizing agent. Activated charcoal is used as an adsorbent in household water filter. It has replaced the use of charcoal as as it is the better adsorbent. Activated charcoal is the better adsorbent, and it is used as adsorbent in household water filter. It is used as deodorizing agent for removing foul smells. Okay, so use of charcoal, different use of charcoals are given. Second form, amorphous form of carbon is coal. Coal is a black hard solid, and it is formed by the process of coalification. Coal is formed by the process of coalification. So coalification involves the conversion of wood or decayed vegetable matter into coal under high pressure, high temperature, in the absence of air, and this process takes millions of years. Okay, there are three types of coals: lignite or brown coal, bituminous coal or soft coal, and anthracite coal. Based on the percentage of carbon present, coals are three types. So lignite coal, it is the lowest rank of coal. Lignite coal, brown coal. So in lowest rank of coal, in lignite coal, carbon 60 to 70% carbon is present. Bituminous coal, in bituminous coal contains 70 to 90% carbon. 70 to 90% carbon. Okay, and bituminous coal is also known as household coal. And anthracite coal, hard coal, it contains 92 to 98% carbon. 92 to 98% carbon. So these are three types of coals. Use of coal, different use of coal. It is used as fuel for industry and domestic purposes. It is used to prepare coke, coal gas, and coal tar. It is the source of different organic compounds such as benzene, naphthalene. Next, amorphous form of carbon is lamp black or soot. Lamp black or soot. Lamp black or soot. Lamp black is the fine black powder. Lamp black is the fine black powder. It is prepared by burning hydrocarbons such as kerosene, oil, wax. Lamp black is the fine black powder, and it is prepared by burning hydrocarbons such as kerosene, oil, and wax. Use of lamp black. Lamp black or soot, it is used as pigment in the manufacture of shoe polish. As pigment in the manufacture of shoe polish, black paint, and colors. And it is also used in the manufacture of painting ink cartridges. Printing ink cartridges. Okay, lamp black is used. Next is gas carbon. Gas carbon, amorphous form of carbon, gas carbon. Gas carbon is a black powder that gets deposited on heating a hydrocarbon in absence of air or during the destructive distillation of coal. Use of gas carbon. Gas carbon is a good conductor of electricity, and it is used to manufacture electrodes, because it is a good conductor of electricity, gas carbon. And coke, what is coke? Coke is also amorphous form of carbon. Coke is a dark black solid obtained as a residue during destructive distillation of coal. Coke is a dark black solid obtained as a residue during the destructive distillation of coal. Use of coke, it is used as an industrial fuel, as it does not produce smoke on burning. It acts as good reducing agent. Coke acts as good reducing agent. Okay, and it is used in the manufacture of gaseous fuel like water gas, producer gas. Okay, so these are different crystalline and amorphous form of carbon. You have to read all the properties and use of different form of carbons. Okay, thank you, students.